see what we're talking about in the video version of Coast to Canopy at wfsu.org/ecologyblog. Here you can also find additional visuals and links to related content and resources. In 2026, Floridians experienced a once-in-a-lifetime drought. One of the most visible effects of this drought was in waterways tied to our aquifer. Springs, sinkhole lakes, and even portions of rivers dried down. Today's conversation is a combination of two interviews with people who work with springs in different parts of North Florida, where some water bodies have been more affected by drought than others. We'll talk about how water moves in the aquifer, how this is affected by the way we use water, and the potential effects of data centers. This is Coast to Canopy, an ecology podcast from WFSU Public Media. I'm your host, Rob Diaz de Villegas. We're here with Ming Yi, the professor of hydrology at the Florida State University Department of Earth, Ocean, and Atmospheric Science and the Department of Scientific Computing. Welcome.
Thank you.
And we're also here with Kelly Keys, who for the last 2 years has been communications director at the FSU Wakulla Springs lab. Welcome.
Thank you.
All right, so I want to start with you, Kelly. So you take a lot of people, you do a Wakulla Springs tour, which I've been talking, in my job, I talk to a lot of people who do ecological things, and I've been hearing more and more people talk about them going on your tour, and they seem to love it. And so talk about, when you take people down there and you see and you show off what is special about it. What makes Wakulla Spring an exceptional spring compared to other springs?
Well, part of it really is that it's an exceptional spring in an exceptional place. So we live, I like to tell people, in the land of 1,000 springs. There's over 1,100 springs in North and Central Florida. And Wakulla Springs, when we say springs, there's multiple springs that contribute to the river, but Wakulla Springs singular is the largest of them. And it is one of over 30 of the biggest springs in the state. Wakulla Springs is exceptional in many ways because it has one of the longest and deepest mapped underwater cave systems in the entire world that feeds that spring. And it's very close to the Gulf, which is also an interesting feature of it. I kind of call it the crown jewel. I'm biased, obviously, in this land of springs that we live in.
Now we head west in the land of 1,000 springs with Haley Moody, director of the Florida Springs Institute. In your bio on the Florida Springs Institute website, it says the Ichetucknee is your favorite spring. Mm-hmm. So I want to start with the Ichetucknee. I want you to describe it, why it's your favorite, and then I want to kind of zoom out and put it in the context of what you call the Springs Heartland.
Sure. Yeah. So Ichetucknee is an incredible system. It is 17 minutes from where I work, so I'm able to get there relatively quickly. It's an incredible system. I really can't say enough about Ichetucknee. It's where I first fell in love with the springs. And I think that's partially because of how the system is managed. Sam Cole is a park biologist there. He's been there a long time, and he takes such good care of that place. He's a specialist in plants. So the submerged aquatic vegetation is it's incredible there. But also, Ichetucknee is sort of unique in the fact that it actually has an established carrying capacity. So this is a science-based carrying capacity. It's based on a study that was done in the 70s at the University of Florida. And they placed a limit on basically how many people this system can sustain. So a lot of the springs that you'll show up to, you may get turned away because they're at capacity, but that's really based on the parking lot size, how many people they can fit in the parking lot. Whereas Ichetucknee, there was actually a lot of thought and care put into how many people can be on that system.
Right, and that's a state park, so I know I've gone there a lot for kayaking and tubing, right? So that's what we're talking about is how many people are actively using that, and also a swimming area, right?
That's right, yeah.
Okay, yeah.
It's incredibly beautiful. The submerged aquatic vegetation is lush and amazing. And the Ichetucknee River has another unique aspect of it is that the entire river is not within a state park. So there is some portion of the lower river that is outside that park boundary. So as you cross over from the protected area into the unprotected area, there is just a stark contrast from what you see. The vegetation really changes. A lot of the vegetation, honestly, disappears because of the types of activities that are allowed in the lower river. So it's just a great example of what can happen with a state park when conservation is prioritized and the system's health is really prioritized. I love Ichetucknee for that reason. And we're actually studying the Ichetucknee this year. So we have a full year-long study. We're about halfway through it right now. So our science interns are getting to go out there and learn about the system too, which is awesome.
I go there, I camp there a lot, and also around the Santa Fe, Suwannee River. And so what I always find kind of remarkable, every time I drive there, I always see a sign for another different spring that's not too far away.
Yeah.
I know you guys are based at High Springs, and it seems like there's just a large density of springs there. So talk about sort of, this is the Springs heartland of Florida, right?
That's right. So Florida Springs Heartland, that's the sort of nickname that the town of High Springs has. And it's due to our proximity to a large concentration of these first magnitude springs. So the springs that are producing more than 65 million gallons per day. So very large springs. And we've got quite a few of them up near us. So some people say the largest concentration in the whole world.
And so the Ichetucknee flows into the Santa Fe into the Suwannee. Mm-hmm. And so I think I read that the Suwannee watershed has about 300 springs just around it, feeding into it. So talk about that and talk about what feeds those springs, like what land area feeds those springs.
So it's really interesting when you look at these rivers on a map. We have a Florida Springs map where all of the 1,000+ springs are mapped, and these two rivers really stand out on that map. It almost looks like they make a figure. It almost looks like a dancer, because there are so many springs lining these rivers that it just shows up as these little dots of blue all along the rivers. There is a reason for that. The Suwannee and the Santa Fe are largely in an unconfined portion of the aquifer. So the water from these springs that's discharging out of these springs is coming from underground. It's coming from the Floridan aquifer. So rainfall, falls on the land surface. It percolates down through our sandy soils and eventually ends up recharging or refilling this aquifer. And then when that groundwater is under pressure, so you can think about it as like if you were trying to fill up a cup that was already full, it would spill out over the top. It's got to have somewhere to go. So that's what's happening with these springs. When that groundwater is under pressure, it ends up discharging out of an opening in the lime rock. And that's what we have here. We're in an unconfined area, which means that there is no barrier. There is no clay layer underground between the land surface and our groundwater. It's pretty much a direct shot from the surface, percolating down through the soils into our groundwater. That just makes a very springs-rich area. Yeah. That's what we find here, which is incredible. But because there is no confinement, because there is no clay layer down there, it also makes it very susceptible to pollution. So any pollutants that are applied at the land surface, they also have a direct shot into that groundwater.
And now a question for Ming-Yi. When we talk about the aquifer, I think a lot of times the way it's explained, it almost sounds like it's a giant cave of water, but it's not all open space like that. Can we get just a really brief, broad overview? Like when we talk about the Floridan aquifer, what are we talking about?
Yeah, essentially we are talking about limestone, and most of Florida is on the limestone rocks, and then limestone dissolved and formed the cave system, and the limestone itself is very porous. So essentially we're talking about rocks, and you can imagine a large chunk of rock with conduit, with a porous in it, and then the water flows.
And so Wakulla Springs has a spring shed, which is the area that recharges it where water falls, and if it gets down into the aquifer, it is likely to come out of the spring. In our area, there are a lot of water bodies we've had an exceptional drought over the last few months, and a lot of these water bodies are kind of dried down. We have a lot of sinkhole lakes, and we see them, Lake Jackson, Lake Miccosukee, they're dried down. And these are part of the spring shed. And we know that when they're dried down, that this means that the upper aquifer is sort of lower. But Wakulla Springs doesn't seem to be as affected as other springs in Florida during this drought. So talk about why that might be.
Yeah, this is a spring. Every spring has you mentioned the spring shed is a concept we borrow from a watershed, but it's for subsurface. Several areas they call groundwater basin, but I think it would be better called spring shed because it has a strong interaction with surface water. So you have to study the spring and the surface water, and also meteorology water. And so this spring is very special, and Kelly mentioned it has the longest conduit system. That means it's a really large spring shed and has resources and water come from not just local, but even from Georgia. So that makes this spring recharge area is very special. And also it discharges to the river. So it's a direct connection between groundwater and surface water. And that water flow into the Gulf. And also there may be connected with other caves that like Spring Creek Cave that connected to the Gulf. So yeah, it's a very special spring shed.
And just to add to that too, since I know a lot of listeners are in the Tallahassee area, and part of what I talk about on the tours is that a lot of people, they might have learned the concept of a watershed in school, but this idea of when raindrops fall, where if they're falling in your yard right outside your house, where are those headed eventually? And that is also related in our region to this concept of a spring shed, because in a lot of areas, there's not so many springs. And so most of Tallahassee, and like Ming said, into South Georgia, that is the spring shed, meaning when the rainwater falls and goes somewhere, that water in this entire region of Tallahassee is headed towards Wakulla, towards the springs. And so people sometimes don't realize how intimate their connection is when they're walking around in the concrete in the city, that water, those water drops are actually many of them can end up emerging at the springs.
Yeah, and then your tour as well, it's interesting. You talk about spring shed and watershed, but it's also kind of a watershed tour for a little bit of it because we're talking about the Munson Slough system. So talk about, you have a lot of water collecting into a system that also then just goes into the aquifer, and talk about, that aspect of it.
Yeah, well, when we talk about these caves, the underwater caves that are literally the pipe system for the spring, that's hard to visualize for most of us, right? Fair enough. And so it helps to start, if we start in Cascades Park, this very famous location in Tallahassee, and we can see the water that's on the surface and we watch it flow through the city, where in a lot of the southwestern side of the city, that water is all flowing to Lake Munson, familiar to a lot of us. If it's not, I encourage people to stop by and see it. It's a beautiful lake. And then it continues flowing southward, and it reaches a spot where it actually goes underground into the cave system. And there's not that many spots on Earth, really, that you can follow a creek that then disappears and you can't follow the creek anymore. And so it's this special thing here that we have these sinking creeks, but that really helps people visualize this idea that this water on the surface that we see starts to travel underground south of Tallahassee, and that kind of helps it click for people that, it's going into this cave system. That cave system travels to the springs.
Every spring has what's called a spring shed. So it's similar to a watershed. Most people are familiar with a sort of a river shed. It's the area of land around a spring that is contributing groundwater to that spring. And some of these areas are quite large. Some of these spring sheds are hundreds of miles across, much bigger than you would imagine. But if, a drop of rain falls within that spring shed, it has some chance of coming out of that spring. It's interesting. I was actually speaking to somebody who was responsible for delineating these spring sheds, and they sort of were kind of making a joke about it, that the entire state of Florida is one big spring shed. I mean, with 1,000+ springs, you could drop a pin anywhere and you're probably in a spring shed somewhere. But the Florida Department of Environmental Protection has delineated the spring sheds for our 30 outstanding Florida springs. Those span the state, and some of those are quite large because the springs are quite large.
I've interviewed people closer to Tallahassee here, and they do a lot of dye traces to figure out what's feeding Wakulla Spring or Wassissa Spring, which are springs kind of closer to here.
Yeah.
When there's that many that close together, does that make it a lot harder to figure out, if there's a swallowette somewhere, where would this water go? Or if I'm pumping, if there's a well here, can you pinpoint it really precisely, or is it a lot harder because springs are so close together? Or
Yeah, it can be challenging for sure. And dye trace studies are a great way to do that. But that can also actually change over time. Where the water is going, where the groundwater is going, and where it's discharging out of, that can actually shift and change depending on groundwater pumping, for example. So things are sort of shifty underground.
Yeah.
Maybe you wouldn't expect it to be, but there are springs that sort of pirate water from other springs. So, it depends, but dye trace studies are a great way to take a look at that.
So now I want to talk about in the last few months, we've been in an exceptional drought. It's interesting, closer to here, Wakulla Spring, if I looked at the gauge of the Wakulla River, it looks like more water is coming out of it. I've talked to people that, when less water is coming from Tallahassee, it kind of takes water, like you were saying, pirated. So it actually takes water and it seems to be flowing really strongly. But how's it working more on some of the springs closer to the Suwannee River? I know some of them seem kind of dry looking.
There are some less obvious ways that this is happening, and then there are some more obvious ways. Because there are 300 plus springs along the Suwannee, there is a significant portion of the flow is actually groundwater. So, historic flow rates have the springs contributing as much as 50% of the flow of the river. So when we're in a drought, it's really challenging because we have a reduction of the surface water flow, but then we also have the aquifer level dropping and a reduction in the groundwater contribution to that river. But we also have pretty significant industrial uses of water that are happening along the Suwannee. For example, one spring that I can think of, White Sulphur Spring up in White Springs. It's a spring at the turn of the century that was super popular. People were coming from all over the country to swim in the healing waters. There were all sorts of hotels and doctors' offices that popped up. But a phosphate mine went in, and in the 70s, it intermittently stopped flowing. And now it has stopped flowing altogether. But the phosphate mine is still in operation. It has changed hands, but, it's pretty clear why that spring went dry. So that's something we'd like to prevent if we can.
You mentioned Spring Creek. Now, Spring Creek is down on the coast. Wakulla Springs seems to get water from possibly multiple different connected systems. So talk about that.
Yeah. It's a complicated cave system. And so we still don't know exactly how big it is. And we got a number Kelly mentioned is one of the largest in the world. I think this is the longest mapped cave system in the U.S. and the sixth largest in the world. So it's pretty complicated. And the divers mapped some caves, but there's still unmapped cave, and we just don't know. Hopefully, new technology can bring us a new opportunity to map the cave system, and then we will know better where the water come from. And there may be multiple layers of caves, because we know from Mammoth Cave they have multiple layers. That's a large cave, and it could be here because sea level up and down.
Right. So talk about that. So we're talking about three-dimensionality. How deep is the aquifer in different places?
Yeah, the aquifer covers the almost entire Florida. There are some sand aquifer in Pensacola, and Biscayne aquifer is separate. For the rest, it's Florida aquifer. And it varies in different way. Like in South Florida, has been eroded, and North Florida is not eroded. So we are in different geological setting. And so in the depths is probably 600 feet. I don't have the number with me. And it has a upper Floridan, intermediate Floridan, and lower Floridan. So we're not using the water from upper Floridan.
The upper Floridan, so that's what's feeding Wakulla Spring?
Yeah.
And then it's also where we get our drinking water, correct?
That's right. Yeah. Same water we're drinking.
So you talked about the difficulty of mapping everything. So recently there was an announcement. And so I want to hear about this new initiative to continue mapping the system. I know we interviewed Chris Warner with the Woodville Karst Plain Project last fall for Costa Canopy, and you're partnering with them. And then talk about, I guess, this new initiative and sunfish.
Yeah, so we were really excited. It was founded last year by legislature, and we start project in February. So we have mapped about 4.6 miles, and we're going to continue the work in the fall doing the mapping. So in the past, we really have really low contact with the spring. The only thing we do like a dye tracing experiment, introduce a dye and see where it come out. but it's indirect. And we also use geochemical data, isotope data, all the tools we have, but they're all indirect. It's essentially you're knocking around the wood and to see where the hole is, and geophysics too. But now we finally got a chance to go down into the cave. It has the sonar system, so we can map the size of the conduit and geometry of it, and can also measure nitrate concentration, for example, temperature and pressure. So we now have a really cool information or data that understand a lot about this conduit system. So we finally got a chance to, like you imagine, we're not a doctor anymore. We are in the conduit. We are in the system, not outside the system.
Right. And so the Sunfish is a submersible?
Yeah, it's called autonomous underwater vehicle. Yeah, it's submersive and it can flow by itself and it's 6-dimensional, so you can just do a lot of things in the subsurface. And also, after it's been trained, it has intelligence and it can make decision where to go and more importantly, come back before the battery is off. Yeah, so those information, we're still processing the data, and hopefully we're going to see a lot of things we cannot see before.
I know when we were talking with Chris last fall, we were talking about just what an undertaking it is to send human beings down there, how dangerous it is. I guess the idea is that the Sunfish can go in certain crevices that are maybe a little too small for a human being to go through. So talk about what that adds as far as what you can map.
Yeah, so there's a lot of things the Sunfish can do and without risking people's life. Probably you heard from Chris, they have to do they use helium gas, and so for under certain depths, probably 200 or 300 feet, they stay in the water for 1 minute. It's gonna take 4 minutes for them to get the helium out. So you cannot do much because you only have humans have limited amount of energy to work in the cave. And so with this robot, you don't need to worry about that as long as the battery is there and they can do the work. So it's probably several times more efficient than us. This is in talking about the length of the work. And also it can go places that divers would not go. It may be just too dangerous or too dark, all kind of situation. And then they don't need to carry a gas tank, and they can carry sensors. So yeah, so new location, longer time, and more data. I'll say that way. Yeah, because the sensor mounted can do a continuous measurement, and just like a fish. Yeah.
Gotcha. And so how physically big is it?
Yeah, the Sunfish is about 5 or 6 feet long, and then this is first generation, and it's portable. You can transport it in a truck or a minivan, probably bigger than trunk we have in the sedan, but a SUV probably can do the job. And then this is first generation, and second generation is more exciting. It's more like a torpedo, and it runs faster, and the battery lasts long. And there are fluid mechanics designed to make it more energy efficient, and it's smaller. So the new one is longer but smaller, so that enable it to go to small opening in the caves.
Kelly, obviously your job is to communicate to people and try to get them to understand, our connection to the aquifer. Why is that important as far as what impacts do we have as far as individual human beings? Do we really affect how much water gets taken out of the aquifer?
Well, sure. That's, of course, at the individual level, it's a little harder, to pinpoint and describe. But I like to tell people to help them sort of understand what's different about here is not just that we have all these springs and sinkholes and sinking creeks and all this really, really cool topography in this place of so many springs, but also that in a lot of regions like south of Tallahassee, on top of this limestone rock that Ming is talking about, we really just have sand. And that means that our aquifer here is exceptionally vulnerable to everything we're doing on the surface. If you think of a Brita filter filters out things, the sand does the opposite. It's like the not Brita thing. And so it just kind of accepts so much of what's at the surface down into the aquifer. And as Ming already mentioned, it's not just the springs, which we all love and care about, but it's also where our drinking water comes from. And so it means what we're doing collectively at the surface, anything we're doing at the surface, we really have to extra consider in this region because of that fact, because our soil is different. And even when you think up into Tallahassee, that soil still has more sand in it than a lot of other regions. And so it still is, even in Tallahassee with all of our sinkhole lakes and everything, there's still a lot of drainage into the aquifer. So that means everything we do here, we have to just take an extra consideration for that.
The flow at the beginning of the 20th century was something like 4.7 billion gallons per day out of the combined Springs, Heartland, Springs, right? And then I guess today it's about less than half of that, 2.3, yeah. So less than half of that. So so you mentioned industrial uses. Is it just industrial uses? Is it agriculture? What's causing this? And also this has led partially to the river being designated as one of America's top 10 most endangered rivers, right?
That's right. Across the entire state of Florida, the U.S. Geological Survey estimates that the largest consumer of our groundwater is actually the public supply category. Mm-hmm. So we are using a little over 1 billion gallons a day just in the public supply. So that's anyone that's connected to a public or privately owned utility company, and that's a lot of people. That is the largest consumer, is people's home use. And we have people moving to Florida all the time. It's a very popular state for good reason. It's incredible here. I can't say enough about our state. I'm over the moon for Florida for sure. But we have people moving here all the time. We have people visiting here quite a bit that also have a significant water use. That's the largest consumer. The second is agriculture. So that's at about 700 million gallons per day. And then behind that, we have commercial wells at about a little over 200 million gallons per day. So those would be like the phosphate mines or the bottled water, for example. So those are the largest consumers. I do like to focus on that public supply category because I do think, we all can make a difference. We're all involved in that, and there are certainly things that we can do in our own homes to save water. But there are some allocations that seem to be a little out of proportion, and it gets really challenging when we're in times of drought to really ask people to, do what they can to save water. I know in the Tampa Bay region, like restaurants had stopped serving cups of water to the people that were coming to patronize their restaurants. They had to actually ask for water. So those things are a little hard to swallow when so much water is being allocated for a single permit for an industry like phosphate mining.
Are there a lot of industrial permits issued in Florida? Because it seems like it's not like a huge amount of number, but that each individual user might use a lot.
So there are quite a few, and again, some will use more water than others. This particular phosphate mine up in White Springs, for example, is allocated over 60 million gallons per day, which is really significant. So I know bottled water gets a lot of attention, but across the state, I think it's all bottled water permits are somewhere around 6 million gallons per day. So that's quite a difference in terms of what people know about and what people are talking about and what people are really advocating for and against. I do think it's important that people have that information. They understand where this water is going.
So we, the consumers, are the ones using most of it right now. A lot of counties are considering whether or not they want to open up for having AI data centers, which are reputably known as taking a lot of water. What would that mean, having AI data centers taking water from the aquifer?
This is a hot topic right now. It is this sort of new industry. It is sort of this new thing being proposed in Florida. It has come pretty quickly, I think. But this is what I will say about data centers. A medium-sized data center could use as much as 300,000 gallons per day. A large-scale data center could use as much as 5 million gallons per day. There are different types of systems. There are open-loop and closed-loop systems. But they both have a direct water use and an indirect water use. And we just have to keep a careful eye on both of those. because the indirect water use from the electricity consumption can actually be quite large, even in those closed loop systems. This becomes really challenging when we see proposals for data centers show up within spring sheds of outstanding Florida springs, for example. There have been 30 outstanding Florida springs designated by the Florida Springs and Aquifer Protection Act of 2016. And those springs actually have legal protections. For example, it wasn't exactly a data center proposal, but it was a land use change in order to sort of move in that direction of a data center in Citrus County recently. That was in the Kings Bay Crystal River Spring Shed at Holder Industrial Park. And it was just a couple of weeks ago that this land use change in order to facilitate a large-scale data center came before the Planning and Development Commission down there in Citrus County, and they actually denied the request. And this was partially because of the public outcry, because so many people showed up to fight back against this. In these situations, what really needs to happen is that whether it comes before the county commission or whether it comes before the planning and zoning board or planning and development board, they both really need to be in very close communication with the water management district. Whatever water management district they're in, they need to make sure that they are requesting a water availability study before approving any sort of request for zoning change or approving a data center. They need to know from their water management district, how is this going to affect the water availability in our area? And if there is an outstanding Florida spring, how will it affect the minimum flow and level that's been established for that spring, or an outstanding Florida water, for that matter, that has a minimum flow and level? The counties and the planning and zoning boards, they really need to lean into the water management districts for that information, for the water modeling, because they're not gonna have that information. They're gonna need to get that from their districts. So that would be my recommendation moving forward. You know, we also have this situation here in Florida with our Lime Rock aquifer. We have sinkholes that form.
Right.
And our water use actually has a lot to do with that. Because we have this vast underground aquifer, in a lot of places in Florida, it's the water that's holding up the land above it. And if that water level drops, and it drops too quickly, the land can drop right along with it. And this is something that, again, if a county or an area is considering bringing a data center, they need to be really clear about that impact of the water use, because sinkholes could open up. And they need to know about that, and they, again, can request a sinkhole susceptibility study from the Water Management District for the water use.
Tallahassee area, we don't have, at least within the Wakulla Springs, there's some agriculture, but not as heavy as other places in Florida. And then we don't have any industrial uses of water here, but in other parts of the state, that's more of a thing. So talk about if we were to get, like, say, I know there's a recent moratorium was passed on AI data centers in Leon County, which isn't a permanent stop to that, but just for a while, we're not going to consider it. Yeah. But if we were to get an AI data center sort of in the Wakulla Springs shed, so what would that mean for the amount of water that would be taken from that part of the aquifer?
And Wakulla County passed that as well as Leon. So I can't speak scientifically, and I'm not going to specifically about a data center, but in a more general sense, right? Like, we live in the East Coast and we know we have a lot of water here, right? And trends are showing even that, like, maybe even slightly wetter, obviously not this past year, but slightly wetter. But we have a lot of rain, we have a lot of water, we have a lot of springs, but sometimes it gets really dry. We know in Tallahassee our sinkhole lakes sometimes get low. Those are natural cycles. And the animals and the entire ecosystem, all of the habitat, all of that is dependent on that amount of water and sometimes that fluctuation of water. And so taking a lot of water out of that system, obviously the ecosystem has over millennia has grown to depend on the amount of water as it exists. Yeah. That's what I would say generally, is that us humans taking a lot out, that we want to think hard about that because of the ecosystems around here.
Yeah, and the New York also have a 1-year ban on data center.
Oh.
Yeah, because they need, I think the governor just signed it a couple of days ago, just 1-year ban, because they need more study. So including like an ecosystem. It's not water, right? So water is to sustain the whole society. So they're going to use a lot of water for cooling. And actually groundwater would be a really good source for cooling water, right? So it's a constant temperature, right? They cool, it's 72 degree here or 69. It's going to cool the system and continuously, right? And it definitely a good water consumption. But if they're using like a closed loop or using reclaimed water, that could save some water resources. But definitely it will need a continuous pumping to cool the system. So that will be definitely a burden to the not only hydrology, to ecosystem. And you mentioned we have so many springs. We have thousands of springs, and every spring is different. But I have not seen a sort of statewide assessment how much water resources we have, because our population is growing. And I heard we have people moving in Florida every day. Right?
Yeah, oh yeah.
We're the third largest state in population, passing New York. And how much water we have, and especially considering the climate condition. So if drought continue like this, can we sustain the enough people, existing people, or look at the infrastructure we have? Do we have leaking pipe that we need to worry? So there, and also ecosystem, right? So I would say it would be very helpful to have a systematic study, and especially nowadays we heard about the word like digital twins with AI technology. It's maybe possible we could build some digital twin of the state of water resource or ecosystems, and then that can support decision making rather than just say, hey, what's gonna happen? I don't know. It's a random thing. But we could have a systematic study, have a tool, and for planning, for management. So that'd be helpful. So that'd be led by some state agency for that effort.
So when you're talking about a resource that's entirely underground, and we have points where we could see, evidence of the amount of water there, whether, it's how much is coming out of a spring in different parts of the state, or in the swalettes when the water in those areas kind of goes down. How do you measure, the amount of water, that's below us?
Yeah, we have a lot of tools for that kind of assessment. So that's we need geological information, need to know what kind of rock, what kind of geological time. And also we using pumping tests to figure out two things. One is porosity, is how much pore space. And then also another thing called hydraulic conductivity, how fast water flows. And then we would have something called a specific yield or specific storage. And then there are formulas we can use to calculate and how much water. It's a rough estimates, and the best tool would be a model. We can develop a model and use a model to look at all the sources and look at water budget. Let's say if you pump X amount of water, how that affect springs, rivers, and what the correlation between different factors. Say if rainfall increase or decrease, how much. Let's say we can quantify things. Let's say if your rainfall increase X, and how much spring gonna increase, 0.5x or 0.1x. So we cannot come from our machine learning, but we can do a model to have a quantification. And those kind of information can definitely help us. Let's say how much water utility we need to build. Do we need to drill new wells, and how deep they can go? So those information will be very helpful to estimate water resources and then have a decision support system for it.
Do these kind of models exist for maybe smaller areas, different spring sheds?
Yeah, they do. Every water management district have that flow model. But we don't have a model for the entire state because the water flow from, say, Suwannee into St. George, but the model itself just limited to their region. So it'd be helpful to have a whole flow system. Well, in the last 10 or 20 years, we have developed a system model, so we can model the entire Earth. So maybe we can use technology to model Florida. So definitely tools are there. It's just time and resources to support and to develop such a tool for the entire state.
Going back to the endangered river status for the Suwannee River,
Yep.
was interested to read that it's the second least populated area in Florida, and yet there's a lot of water being taken from it from other locations. So I guess talk about from how far away is water being taken from the Suwannee River?
So the city of Jacksonville, actually, as far away as Jacksonville. Jacksonville is an enormous city,
Yeah.
and has a significant water demand. And this is one of those situations where, the water use is actually being pirated from the Suwannee Valley. So as far away as Jacksonville.
How do we help this endangered river? Is it just looking at places as far away as Jacksonville and how they use water, and then all the rest of us? And even between Jacksonville, St. Augustine, down to Daytona, that whole coastline is pretty well populated.
Well, I think everyone needs to start with looking at their own water use. I mean, I think that's where it starts. It starts with you. I'm somebody at home, I shower with a watering can because I am that type of person. Once you start thinking about ways that you can save water, I mean, you'll start to see them everywhere. We have a Florida Springs Friendly Yard program. So that's really requires no groundwater withdrawals for the ornamental landscape. And that's a program you can find out about on our website, and you get a yard sign so your neighbors get really jealous of you. And it can start a conversation. So personal water use is where you start. Beyond that, it's really informing yourself. It's finding out as much as you can, attending lectures, showing up at Springs conservation events, just finding out as much as you possibly can, and ultimately voting like your water depends on it, because it does. When, the election cycle starts, taking a good look at the candidates and where they stand on water use and conservation, that's a big part of it. Yeah.
We've been filming a lot of election forums here at the station for a lot of our city and county commission, and that question, the AI data center question, comes up a lot, but I guess it could be bigger than that as far as water usage too.
Yeah, water use and also land conservation. That's a big piece of it too. We need to make sure that there's enough funding in the state to conserve large areas of land. I mean, this is really what protects our groundwater, which is our drinking water. I mean, the USGS estimates that 92% of Florida's residents and tourists rely on our groundwater for our drinking water and all other uses. So this isn't just, so that you'll be able to go swim in a spring and recreate in a spring and kayak and have fun with your friends. This is your drinking water. This is fundamental to life here in Florida. So it's that important.
So you're talking about parks, national forests. We have some pretty good ones here in Florida that take up a lot of space, and that's recharge area, right?
That's right.
Yeah. And then going back to, because a lot of my work I do, not a lot of it, but I mean, one of my favorite things to work on is sort of building the home habitat outdoors. And so when you're talking about the drought-friendly landscape is also, it's native plants that are adapted to our dry soils, which are also good for bees and butterflies and
That's right.
everyone who likes to see monarchs and everything else in their yard. I mean, that's sort of the same kind of plants we're talking about, right?
That's right. Yep. Florida natives.
Let's talk about drought.
Yeah.
We're in an exceptional drought. We see dried down water bodies. And, even as much as I go out of my way to explain, cycles of things, people are distressed at just the thought of drought. So let's talk about the natural cycles of drought before we talk about what maybe is an exceptional drought. When do we start getting concerned?
Yeah. Yeah, I think Ming might be able to hop in and talk a little bit about the groundwater table and things like that. But as far as natural cycles of drought, so I just have to be, my husband has worked in wildlands fire for over 30 years. So we talk about this all the time because fire is a big topic in our household. And in our region, we do actually have these natural, very extreme droughts. It's kind of a normal thing for us to have those. And so this one that we had from the past September to April, that was since the 1880s. It was like the most extreme, but it's still in a pattern of these cycles where it gets really super dry. And our springtime was sort of a natural drought, but what happened was before springtime, we had drought then too, which was a little more unusual and put us into that extreme drought situation. And so of course that affects the groundwater, but in our region overall, we're not on the overall year to year, we're not getting dry drier. And so in the moment, drought can seem really scary as it relates to fire and things like that. But overall, it's not an indication that the trend is that we're getting drier. That's not happening.
Our wildlife has evolved with this too. And that's the thing, when I write about Lake Jackson especially, well, there's fish flopping around, but the fish don't disappear, right? I mean,
yeah, the wildlife here is adapted to regular cycles of drought and fire. And so it's actually fire dependent in our region. And of course, we get scared of wildfire when it gets super dry. And that's natural, like we're humans. But one of the best things we can do to protect ourselves from wildfire in this region is to actually support land managers using regular controlled burning, which a lot of us are familiar with, but where they purposely will light fires. And that is very protective, both of the animals, which are expecting regular cycles of fire, but also of humans who don't really like wildfire. But these regular cycles of fire are as natural as rain in our area, and the animals know what to do about it.
But we have different definitions of drought in different communities. The first level is the drought of agriculture. You see the crops are dead and grass are dead. That's the first level you experience. And then the next level would be hydrology. So let's say rivers stop flowing. And then the last level is groundwater. And then you see water level just keep dropping, never come back. And then you say the drop is really, really serious. And then a couple months ago, we have the extremely drought is over 100 years. So that means really extreme. Yeah, think about the Tallahassee history is 125 years. Right? So almost nobody have seen that kind of drought in the past. And then also for the groundwater here is very special. It has a strong connection with surface water. So let's say we have a well outside of our department building, and after Tallahassee receive a large amount of rainfall, you can see the water level. We have monitoring data just rise 1 or 2 feet. It's substantial. Yeah. So that means if we have a surface drought, and groundwater will be affected directly. But luckily, we have a large reservoir of groundwater, so we still have drinking water, everything. But if this summer, if we don't have hurricane or not enough water supply, what's going to happen to the fall and the coming spring, right? So this is, I think it's beyond hydrology, also meteorology, and also climate change, if we are allowed to say it.
Right.
Yeah.
Oh, we are allowed to say it on air. Yes,
Yeah,
of course.
sure.
And you talked about, the data goes back to 1895, I believe, is when you look at like the drought, at least the tools I've seen, I guess weather stations that have been monitoring these things. So when we talk about these trends, we only have a kind of a sliver of the time that we don't really, I guess there's some other data that might let us know about things before that, but we're only talking about 1895. Is that about right?
Yeah, and there are a lot of study. They interview Native American. They have some oral history about drought, and also they can look at isotope, look at the isotope in the sediments or in the trees, and there are signature of drought. I don't recall study in Florida, but there are tools in scientists toolbox can do more study.
Florida Springs Institute. Talk about your organization. What is it that you do specifically to research and communicate about rivers and springs?
Sure.
And springs? Yeah.
Thank you for asking that. Yes. So the Florida Springs Institute, we are located up in High Springs. We're on Main Street there. We have the Florida Springs Welcome Center, which is open to the public all during the week and then also on Saturdays. We have museum exhibits. So we have a full manatee skeleton. We've got a mastodon jaw replica. We have all sorts of history signage about Florida Springs from Rick Kilby, who is a great historian here. And there's an interactive Florida Springs map where you can locate all 1,000 Florida Springs and click on each one and see an image and some of the data related to it. Yeah, we have that Welcome Center. You're more than welcome to come see us and talk to us about the Springs. We have our Springs Academy lecture series, which takes place up in that Welcome Center. That happens once a month, where we have a Springs expert that comes and talks to the crowd about the Springs. The next one is actually tomorrow. And yeah, we have a science team that goes out in the field and they conduct these large ecosystem health assessments. And so they take on one system at a time. And in the vein of Howard T. Odom and systems ecology, they really try to look at as many parts of that system as they possibly can. So they're collecting all kinds of data, water quality data, but also submerged aquatic vegetation, fish, birds, snails, all kinds of things. And they're finding out as much about the system as they possibly can, and then it culminates in a report with restoration recommendations. And let's see. I think just a little something I would say about our current study on the Ichetucknee that has just been really successful. Because we're a nonprofit, I think we sit in this really interesting place right between the general public and agencies and institutions. So we have this direct access to the public that are coming through our doors all of the time and asking us questions online and submitting to our contact form on our website. And the Ichetucknee is such a great example of how we can be the bridge for these different groups to come together over a system. There was a woman who lives on the lower Ichetucknee who swims it every day, and she identified an invasive plant, hydrilla, that had never been there before. In the Ichetucknee, had never been seen there before. And so she let us know about it because she comes to our Springs Academy lectures and contacted us, and we went out and verified that was what she was looking at. She contacted FWC, and so now our team is in the process of working with FWC to remove that hydrilla and continue monitoring it to make sure that it doesn't reappear. So it's a really great example of how we can bridge the gap between the public and these agencies and be a part of, being able to respond to a threat in a system immediately.
Yeah.
So let's see. Other than that, we have our Springs Watch program, which is our citizen science program. It's with a small team. It's really how we're able to collect data all the way across the state. So we have citizen science teams at 13 different spring systems now, from Wakulla all the way down to Weeki Wachee. And it's an incredibly successful program. People love it. They get the water quality equipment. They get trained on how to collect these measurements. And they're out there every month collecting data on their home system, their spring system. And it really just creates these ambassadors for these springs, people that just really, really care and are invested in their system and in keeping it healthy. So yeah, that's a little bit about the Florida Springs Institute. We have all kinds of reports, and everything that we've been working on is on our website at floridasprings.org. And I hope that you'll come see us sometime in High Springs.
I might. And, just the one last thing I want to mention. You mentioned mastodons. And so I was at the Ichetucknee a couple years ago. There's a full mastodon skeleton that's eroding out of the bank. I was out there with archaeologists that were mapping it. And it's part of a documentary we did on submerged prehistoric archaeology. And springs are a hotbed for mastodon skeletons and all kinds of really cool archaeology, too. So just another, it's just the limestone, I guess, is really good at preserving skeletons. So,
right. They are these great record keepers. Yes.
Yeah. So thank you so much for coming in today.
Thank you for having me.
Number one, that I just really appreciate Ming and the work of all the scientists. We have a science team for the past 2 years in the Wakulla Springs lab, too. The work these scientists are doing is so important to all of us. And giving them the time and space to do that, super important. Number one. And number two, I love the cave system is so fascinating to me. And I love talking to cave divers and scientists and hearing about the robot, super fascinating. But it's also really important to me for people to recognize that the cave system is not the only contributor to the whole system. And so that even if you live in Tallahassee or South Georgia or a part of Wakulla County that's not on top of the cave system, the entire region, everywhere, everything we do on the surface is contributing. The water falling on the surface as it hits the land, anything it picks up in terms of chemicals or toxic things or fertilizers, things like that, or for the good. Like we have a huge national forest here, which helps really help keep some of that water that's going to the aquifer cleaner. And so everything on the surface matters, not just the cave system. It's everywhere. And in our region, generally, that's flowing southward. And so I get that question sometimes on the tour. So, Tallahassee's to the north of the springs, flowing southward. And just that I said it at the beginning, but I'll say again that it's so unique and so cool here. And I really encourage people, if you're not as familiar, to just get out and experience it, because it's just not very many places on Earth are so special.
And we've been talking about quantity in this episode, but you bring up, as far as water quality. Now, what's the quality of the water coming out of Wakulla Spring right now?
The state have that TMDL, total maximum daily load, is actually start from federal EPA, and the state have their own rule. So the Wakulla Spring was in a bad shape and with really high nitrate concentration or nutrient concentration. And so the water treatment plant, that's an interesting story. They spent a lot of, I think it's $45 million to upgrade the system so they can reach. I took a tour. They told me the nitrate concentration out of the treated wastewater is 1/3 of the national standard. So we're doing better than the EPA standard. And so that helps a lot for Wakulla Spring water quality. And so, but we're just still limbo around the standard set by the TMDL for nitrate. Sometimes it's better, sometimes it's worse. So the job is not done. Still, there are source of contaminants or nutrients in this case coming to the spring. So it's okay. And the glass bottom boat is an example. Because of chlorophyll A or other things, sediments maybe, we still cannot offer the glass bottom boat. So that's an indication the water quality was not as good as before. It's better than probably 10 or 20 years, but definitely not as good as before. Yep. And we have USGS has a monitoring station. I have not checked data recently. It's just mounted on the boat ramp or the deck area, and so they have real data. So everybody can go to USGS website to check the data for nitrate ammonium concentration.
Oh, wow. That's cool.
Mm-hmm.
And for newcomers to the region, because we've been talking about how we have a lot of new people. In the past 15 years in Wakulla County, I think the population has doubled.
Oh, wow.
So some people aren't even aware that we used to have these glass bottom boat tours,
That's
And
right.
so people have been living here a long
right.
time. We remember them. But there's glass bottom boats that used to hover over the springs, and you could see very far into them. And so mostly those don't run anymore. But
yeah, that's right. I live in Tallahassee for 20 years, and I never took one. I got a chance to take one. Maybe when I heard the news, it's already too late, and the water quality is not that good anymore.
Right. So they do boat tours still, and you can see the wildlife on the surface around the spring. But I think it's like 1 or 2 days a year on average for the last. It depends on certain conditions. Every once in a while, it's able to happen.
I don't know the exact number, but the boat tours that do exist are absolutely outstanding. It's one of my favorite things to do in the entire state because it's such a wild river. When you travel down there, the regular boat tours still exist. They're running every day. They're absolutely fantastic. If people aren't familiar with them, definitely go check them out.
Definitely. I went to Silver Spring, and they offer a boat tour too, also glass bottom. But I think the Wakulla Spring boat tour is much better because you see more things and more birds, more turkey, more alligator, So I like this Wakulla Spring boat tour. Kelly, the tour Kelly is leading is really great. And I lead my student to those places too, but I only can reach like 20 students or 30 students in my class each semester. But Kelly can show more to people. And this is really sort of, I guess, it's going to open eye to many people. So let's say connection between Wakulla Springs, not just a one spring vent, is outlet of the whole system, right? And so also there are a lot of things we have to let people know. For example, nitrate concentration. When nitrate concentration high, it doesn't affect the water, doesn't change the water color. So you can have really high nitrate concentration, but your water is still very, very clear until algae grow and chlorophyll A comes and become green, right? So that'd be too late, right? So education would be really important. And I mentioned the USGS has monitoring data, but you have to go back to your computer. But I heard they are building a new science center at Wakulla Springs.
There's a new environmental ed center being built.
So you can imagine.
If you're there, that's that huge walled-off fenced area.
Oh, okay. Yeah. I've been seeing that for a while now, actually.
Yeah, that's what that is. Yeah.
Then you can imagine if you have USGS data projected to a screen and people see, oh, here's the pH, here's the temperature, that'd be really helping, right? Because we see the data, we see the graph. So that would be one way to educate people. And a lot of people and have a basic understanding, but in order for protection, we need people to have more understanding, to understand why that happened and what should we do. And so those, I think Kelly did an excellent job for that tour he's leading.
Thanks. Yeah. And to hop onto that it's just this. What Ming is saying is recognizing that you're connected to the water no matter where you are, right?
Yeah.
And then, and also to clarify with the tours, there is the boat tour that's part of the state park, which is a different entity, of course, and it's got its own boat tour. And then the tours that I give are called Waters of Wakulla tours, and they start in Tallahassee and end. So the state park is our end point of those tours. So Wakulla Springs Lab is on social media, FSU Wakulla Springs Lab. If people want to hear that we don't have tour dates posted yet for the fall, but that's just to clarify that there's actually 2 different tours you can take. Yeah.
That's right.
And you mentioned earlier that, starting the tour, Cascades Park. Mm-hmm. Now, I went with you on tour, and I guess when you do it with FSU students, do you want to start at Doak Campbell Stadium?
We do.
So talk about that connection. So for FSU students who might be listening, how is Doak Campbell Stadium connected to Wakulla Springs?
Mm-hmm.
Yeah. Hey, FSU students. We're both professors. So, hey, all of you. When I do tours with just FSU people, we start at Doak Campbell Stadium. And south of the stadium is this little creek. And it's like an urban creek. And that creek is the entire drainage point for campus. So if you're ever near the stadium, walk over and check the creek out. And that creek flows into the same system that we've been talking about, same as Cascades Park. It flows southward, and you can actually follow it. If you want to drive along and look at it with your own eyes, you can do that. And it flows into Lake Munson, which then flows south, goes underground, enters the cave system. And as Ming has said, we have dye traced that. Scientists put dye into this creek that goes underground, and then that dye came out at Wakulla Springs. So FSU is a very, very direct connection to the springs. And I love when I get students on the tour who are not from the area, and literally their eyes just pop when they understand that. And a lot of them haven't been to the springs ever. Wow. And so it's like a really new connection for them, and that's fun.
Maybe you should do it on the FSU football game day.
It's not far from where a lot of people tailgate. I mean, you really just, hey, come over here.
Have a mini tour for 50,000 people.
All right, Ming Yi, Kelly Keys, thank you so much for being on our show, Coast Canopy.
Thank you, Ming. Thank you, Rob.
Thank you, everybody. Yeah.
If you enjoyed this conversation, you might want to check out our talk with Chris Werner of the Woodville Karst Plain Project, who has been mapping the caves of the Wakulla Springs system. If you've been listening, you can see footage of those cave explorations and of the waterways we discussed on this episode on the video version of Coast to Canopy. You can find that at wfsu.org/ecologyblog and on the WFSU Ecology YouTube channel. This podcast and the WFSU Ecology blog are made possible with support from viewers and listeners like you. Thank you. WFSU is both an NPR and PBS station, and we can't serve our community without your support. For a $10 a month pledge, you can join the WFSU Seed Circle, and I'll give you a shout out on this podcast, like right now. Thank you to Thomas Beeson, Karen Berkeley, Margaret Bivens, David Blair, Beth Garraway, Carol Goodyear, Veronica Humphrey, Lisa Johnson, Chris McFarland, Carrie Maddox, Clara Mullins, Mary Pohl, Alina Pryor, Thomas and Helen Roth, Dylan Riles Hamilton, Kim Sash, and Donna Tharp. We've also had several smaller donations which I truly appreciate. Any amount helps. You can join the Seed Circle at wfsu.org/ecologyblog. And now I want to put in a plug for those of you closer to Tallahassee and Wakulla Springs. On Sunday, August 9th, I'm giving a presentation to the Friends of the St. Mark's National Wildlife Refuge about a topic near and dear to my heart: native bees. I've been photographing and writing about them for years, and they've taught me a lot about the seasonality of our area. This is a free event at the Wakulla Environmental Institute in Crawfordville. There's more information at wfsu.org/ecologyblog. This has been Coast to Canopy, an ecology podcast from WFSU Public Media. Today we had Taylor Cox running audio and Jason Acuna directing video. And I am your host and producer of all things ecology at WFSU, Rob Diaz de Villegas.